Lesson 4 of Chapter 4 is on graphing sine and cosine functions. So if you take a look at these two graphs, the graph on the left is a sine wave. The graph on the right is a cosine wave. They are very similar looking graphs. However, there are a couple of differences. Both of these graphs have a period of 2 pi, and that's the length of one wave, or one cycle. The sine function has an amplitude of 1, and a cosine has an amplitude of 1, and the amplitude is half the height of the wave. So you can see that both of these graphs have a height of 2, so the amplitude is 1. The sine function goes through the origin 0, 0, right here. The cosine does not go through the origin. It has its high point right on the y-axis at 0, 1. So keeping that in mind, we'll discuss changing amplitudes on graphs. Here's a picture. If you take a look at 3 different sine waves, the blue one is just sine of x. The red one is a vertical stretch of 2, so it goes up higher and down lower. And then the green one is a vertical shrink of 1/2. But each of these graphs have the same x-intercept, the same period. They just have different amplitudes. If you take a normal sine wave, like the one you see in red, and if you reflect it vertically, you get the blue one, which is negative sine of x. So, to graph some functions, number 1, we're going to graph sine of x and 1/2 sine of x. So the first thing I'll do is set up my vertical scale and my horizontal scale. Now the period is 2 pi, so I'm going to set up my scale so that 8 boxes represents the period. And so to graph a sine wave, the first point I plot is 0, 0. Then I go to the right, it's period. Right in between those, I'd be back on the x-axis. Right in between those, I'd be at a height of 1. Right in between pi and 2 pi, I'd be at a low point of negative 1. Here's one cycle for a sine wave. To continue with this pattern, to the left, so that is a sine of x. Now if we graph 1/2 sine of x, it's going to be pretty much the same graph. We're going to have the same x-intercepts, but the high point will only be at 1/2 and the low point at negative 1/2. So there's the graph of 1/2 sine of x. Number 2, this time we have a vertical reflection and a vertical shrink. So let me set up my y-axis slightly different. I'm going to make 3 boxes represent 1 unit here. Still going to set up my x-axis the same way. I like to use 8 boxes for my period length. And so to graph a cosine function now, we start with the high point right on the y-axis at 0, 1. Its period is 2 pi. Its low point would be at pi, negative 1. X-intercepts right in between. Here's the 5 points I would plot to draw a cosine wave. And that is one cycle of a cosine. So to continue with that pattern, graph looks something like that. Now to graph g of x, we have to reflect that and shrink it. So therefore its low point would be here, its high point would be here. X-intercepts are the same. And there's a cosine wave with a vertical reflection and a vertical shrink. Next one, we've got a vertical stretch of 6 happening. So I'm going to set up my y scale like this. And let's see here, I'm going to keep the same axis, same labels on my x-axis. So if we graph just a cosine wave, now its high point is at 1, and this is 1. Its period length is 2 pi. So this one seems pretty condensed compared to the last graph we've drawn, but based upon the scale, it hasn't been stretched or shrunk. It's the same thing. So there's a cosine wave. And then if we draw 6 cosine of x, it's going to look pretty much the same, except for the high points will be higher, low points will be lower. X-intercepts are the same. So that shows a vertical stretch of 6 for a cosine wave. Next one, we have to show a vertical reflection for a sine wave and a vertical stretch of 8. So I'll set up the y-axis like this. Still use the same scale on the x-axis. So if I just draw a sine wave, always start at the origin. Its period is 2 pi, right in between those. High points at 1, low points at -1. So that's just a basic sine wave. You continue with that. So there's a sine wave. And now if we take that, reflect it, and stretch it, got the same x-intercepts. But now we'd have a low point here and a high point here. Okay, so I've just shown you 4 graphs with vertical expansions and compressions and a couple of vertical reflections. So next I want to talk about changing the period. And we talk about sinusoids, and a sinusoid is an equation that's written like this. Now the A value affects the amplitude, the B value affects the period, the H represents the horizontal shift, the V represents the vertical shift. Now we're going to discuss changing the period. The period is equal to 2 pi over B for a sinusoid. The H represents your horizontal shift, and then the V represents your vertical shift. So you can take any sine wave and write it as a cosine wave, and any cosine write it as a sine wave with shifts. Well, here if you take a look, there's 3 graphs of cosines. You can see that the blue one is just a cosine of x. The green one is 0.5 cosine of x, which represents a horizontal stretch of 2. And then the red one is the cosine of 2x, which represents a horizontal shrink of 1/2. So, number 5, we're going to graph a sine of x and a sine of 4x. So both of these, I'm going to have a vertical scale going from -1 to +1. Now the period for this guy is going to be 2 pi over 4, which simplifies into pi over 2. So keep that in mind. 1, 2, 3, 4. So I'm going to stick with this same scale. So now to just draw a basic sine wave, we start with that point. So there's the 5 points for a sine wave. Continuing with that pattern. So there's a sine wave. Now if we graph sine of 4x, it's got a period of 1/2 a pi. So I have to draw 1 cycle in between every 1/2 pi units. So there I've just drawn 2 cycles. Now I've got 3 full cycles of 3 wavelengths for the sine of 4x. Next one, number 6. Again, my amplitude is just going to be 1. Now the period for this guy is going to be 2 pi divided by 2, which is pi. So let's keep our same scale. So to draw a cosine wave, we just start with the high point at 0, 1. Its period is 2 pi. Low points at pi, x-intercepts. So there's a basic cosine wave. Now if we graph cosine of 2x, we have to take that and shrink that by 1/2. So now the period is going to be pi. So there's my high point. Here's another high point. Here's a low point. X-intercepts. And that would be the cosine of 2x. Next one, we have to draw a cosine of 0.2x. So the period here would be 2 pi divided by 0.2, which would simplify into 10 pi. So keeping that in mind, vertical scale we can keep as 1. So I'm going to make that 2 pi. Make that 8 pi. So if I graph just a basic cosine wave, I have to draw one cycle in between 0 and 2 pi. So there's a basic cosine wave. If I draw another cycle, there's 2 cycles worth. There's 3 cycles. And there's 4 cycles. Now for the cosine of 0.2x, that's a stretch. So we start with this point. I go to the right 10 pi. I'm running out of graph to the right. So halfway between 0 and 10 pi is 5 pi. So my low point is going to have to be here at 5 pi. 2.5 pi would have an x-intercept. Low point. 7.5 pi would also have an x-intercept. Let's fix this over here. This would be negative 8 pi. Negative 7.5 pi would have an x-intercept. So that'd be the graph of cosine of 0.2x. Last one I want to go over is graphing a sine of x along with a sine of 0.25x. So this will have a period of 2 pi divided by 0.25, which simplifies into 8 pi. So I'm going to keep my vertical scale the same. And to show a period of 8 pi, let's keep that same scale as the last problem. So that's 2 pi, that's 4 pi, 6 pi, 8 pi. So just a basic sine wave, I have to draw one cycle between 0 and 2 pi. So here's one cycle, one sine wave. If I draw another cycle, it would look like that. There's 3 cycles. And there's 4. Now to draw a sine of 0.25x, that's going to be a horizontal stretch of 4. I have to draw one cycle between 0 and 8 pi. So, plot these 5 points. Here is a sine wave that shows a period of 8 pi. And there are 2 sine functions.